Hello students, I'm back in the lab here to help you with some exercises from Organic Synthesis 4. Here we go, here are the first three. Remember why you're working on these, right? Use your free gift. I gave you this for a reason, right? The point of this is not to have all of these memorized right this second. The point of this is to use your mind to think about how you can solve these exercises. So make sure you have this out. Remember those hints and tips about solving organic synthesis. Remember to count carbons, look at the carbon skeleton to see how it's changed, think about what reactions are possible, think about eagle view versus mouse view. A lot of times you want to start off maybe with eagle view and then switch to mouse view as you sort of move along. So let's take a few minutes and sort of debrief these. Let's start with number one. Here's my reactants, products. Retrosynthesis is going to help us with this one, because if you look at this and you think about like, what was the last step, right? We have an ether, that's a ring, right? So this is the Ouroboros, the snake biting its own tail. In order to make that ether, I must have had a linear compound with the two ether reacting components on either side, right? So I know my last step probably looks something like this. Here's my 5 carbons, 1, 2, 3, 4, 5, and then I know I had an alcohol on one side, some sort of halogen on the other side. Let's call that bromine just for kicks, right? So I know that using Williamson ether synthesis, if you add potassium or sodium, you could form that ether. So I know this is likely my last step, okay? So the question is, how do I go from this to that? Now it's a lot more straightforward, right? Because I have an oxygen group here and one here. And I just have to make sure that somehow I get rid of these and convert one of them to here, right? So when I go back to the beginning, I'm thinking, well, let's see. I might want to start with getting rid of these jobbers. I know that that's some sort of Markovnikov electrophilic addition. Notice that this bromine is here on the end. It's on the terminal carbon. And that suggests to me not Markovnikov, but anti-Markovnikov. So I might start with some HBr and our good buddy benzoyl peroxide for some anti-MEA. The anti-MEA is going to give us something like a bromine here. And then in this position, it was equally substituted. So you're going to mix of different things. You'll get about 50% of molecules where the bromine is here, 50% where it's here. It doesn't matter because we're going to get rid of that in a second anyway. So here is step 2. All right, now I want to get rid of this one, but not this one, right? So I want to do an elimination. That's not bad because we can't eliminate things that are primary. We can only eliminate secondary or tertiary. But how do I make sure that when I eliminate this, it doesn't just get substituted for an alcohol, right? If you add OH minus, because this is a secondary position, you might get some substitution, unless you use our special reagent, LDA, right? So this is 2 anti-MEA. If you add some lithium diisopropylamine, this will get eliminated. You're going to get that double bond reforming either here or here. Let's call it here. Okay. Now we can add hydrogen in the appropriate catalyst for a little MEA. That will get rid of this. Oh, and now we're close, right? In order to get from here to here, all we have to do is, right, a little reduction. So use your favorite. Here's some sodium borohydride for some gentle reduction. And then we're going to end off with this one, Williamson ether synthesis, right? So somewhere around 5 steps looks like. Let's go on to number 2. When you first look at number 2, you might have been confused because you might have looked at that and you've been like, what is that? CHO? Right? Is that an alcohol group? It's not an alcohol group, right? This would be CH2OH if these were alcohols. So this is the convention for an aldehyde. That's what CHO means. It's an aldehyde, right? So you could rewrite this if you wanted to, right? Something like this. Here's that H. So we want to take this and convert it into an aldehyde. That's what's going on there. You'll notice when you inspect number 2, the carbon skeletons are actually the same, which means we just need to move the functional groups around a little bit, right? So again, you can do this in a couple different ways, but I would start off with some HBr or HCl, right? That will, oh actually, I don't want to do that first, right? Because if I add HBr or HCl, it's going to actually react with these groups. So probably I actually want to take care of that first. So let's back up and let's add some PCC, some pyridinium chlorochromate for some gentle oxidation. That will go ahead and oxidize this to what I need. Bam. Now, with impunity, we added HBr last time. Let's add HCl. Right, so this is some gentle oxidation. This is some MEA. Remember, we're going to get the Markovnikov product, which means chlorines sticking here and here. All right, now I'm getting closer to this, but I still need to move them further down. I know if I do some elimination, you can use either OH- or LDA, your choice. Because we're eliminating halogens with base, this is E2, not E1. Now I'm going to form, not the Markovnikov product, but when I eliminate here, right, I'm going to form the Zaitsev product, which will either be this, or you could also form here, and when this one can form the same thing. So you might actually get a mix of products here, but this product you're going to form a whole bunch of, right? First of all, this is the same thing as this. Those two products are exactly the same. And also notice something special about this product, right? We have double, single, double, single, double, single, right? This is a conjugated product. Remember, conjugated products are lower in energy, they're more favorable. They tend to be the products that you form most frequently. So you're actually going to form quite a bit of this, right? You might still form some of the other, but this is going to be a major product. And now we're almost done. Now we just need some anti-MEA. Oops, I did this backwards. All right, with some HBr and our good friend, I'm just going to abbreviate it, but you should be able to write it out, benzoyl peroxide. And that should get you to that. All right, last but not least, number 3. Here's the product, here's the reactant. We have a ring, we need to bust that ring apart. Actually, the carbon skeleton is the same. It's 4 carbons in a row here, 4 carbons in a row here. We know that there's 3 different ways to take apart an ester. 3, right? There's ester hydrolysis, powerful reduction, also saponification. In this particular case, we notice that these things are the same as each other, right? So when these are the same as each other, we might be looking for powerful reduction, because powerful reduction is something that gives us the same on both sides. So if we do powerful reduction for this one, powerful reduction, you remember that is dichromate with some sort of acid catalyst. That's going to rip this sucker apart, make this an alcohol, yoink, make this an alcohol. This is now dangerously close to that. All we need is some HCl, our good friend SN2, and we did it. See? It wasn't too challenging, was it? I knew you could do it.